In preparation for this video, I've done something a little unorthodox. I've tried to create the buggiest, worst app I've ever made, because this video is where we'll be talking about troubleshooting and debugging when developing in the Aquro App Studio. In this app, we've got 3 different pages that we'll use to try and troubleshoot 3 different types of issues. First, let's jump into the source code page. Or, apparently, we can't. Let's figure out why this button doesn't work. The first tool we'll use in this debugging session is the debug window built into Aquro App Studio. You'll find this by clicking on the little bug icon on top of the preview window. To get an empty work log to work with, let's click on the clear button, then go back to the preview window, press the button in our app, and reopen the debug window. We can see 3 lines in the debug window, which are all coming from the page.load call made from the script. Every code block used in any visual coding script returns 3 log entries in the debug window. One for when the code block starts, one for when the code block is finished, and one for when it's time to move to the next code block. Let's have a look at the log from when the code block started. On the right side of the window, we can now see some details about this event. Under Event Data, we can see the arguments that were sent to this code block, and here we can quickly see that the reason the page never loaded is because we're loading the home page, not the source code page that we're supposed to. In other words, we must have misconfigured the coding block in our visual coding script. Let's fix that by closing the debug window and opening up the visual coding script for the click event on this button. As you can see, we've connected the home page to the page argument. Let's fix that and resave the script. And now our button works as expected. So that's the first debug tool you have available when working in your app. The built-in debug window is perfect to work with, especially when you're working with visual coding scripts, as you can easily follow the arguments sent to each block and the result of different blocks that are displayed. The next tool that I'm going to use is probably the tool that I use the most when developing apps, and that's the developer tools built into Chrome as a browser. Let's say we'd like to examine the source code of this app. I can simply right-click on the panel of the page and choose Inspect. Once the developer tools have loaded, I can see the source code of this panel, and I can also see things like the active styles for the selected element. What's even better is that I can simply modify the style directly in Chrome. For example, I can easily add some border radius to this panel by editing the CSS. I can also go to the Console tab of the Developer Tools and get an interactive JavaScript console directly on my page. For example, I can check values or execute JavaScript code to try different things out. Let's check the value of the page.current page. And yes, this is correct, we are on the source code page. Learning to use Chrome development tools can greatly improve your troubleshooting skills and also help you develop your apps quicker, as you can try out JavaScript and CSS code in real time. Chrome development tools is thereby the number 2 tool we'll probably check in with from time to time while troubleshooting and debugging. Next, let's see what's happening in our app when we run into a JavaScript error. And luckily, I've prepared just such an error. Just by going to the JavaScript error page, this will trigger a JavaScript error in our app. And as you might have seen, the bug icon in the top of the window turned orange, meaning that a JavaScript error has been thrown. I can now either use the built-in debug window or Chrome developer tools. Let's start by opening up the debug window. Here we can see that one JavaScript error has been logged to the debug log. If I click this error, I can see the message and see that the JavaScript has told us ALER is undefined. I suspect this is a typo. However, let's also start the Chrome developer tools, which in some case might give us more information. I'll find the debugging tools by going to the menu, then More Tools, and finally to Developer Tools. As you can see, Chrome Developer Tools gave us the same information, so we'll need to try and find this error ourselves. Let's close the debugging windows and open the JavaScript error page and go to the Scripts tab. Here, we can find our typo, ALER, which should be alert. I'll change that and save the page. And now the page should work as it's intended to. For the next demo, I prepared a script that will simply check the platform we're running our app on and then show this in a message box. Let's head over to the Scripts tab on the Show Platform page and see the script there. As you can see, the script will check the value of device platform and either show that the user is running on Android or iOS. To test this, I'll therefore head over to my Android phone and check the app there. The app tells us that we're running on an unknown platform, so that must be wrong, as I'm running on Android. To debug the code running on our phone, we can use tool number 3, our built-in remote debugging solution. Activating remote debugging can be easily done in our app by using a specific coding block. Go to the home page and edit the after loaded script. To activate remote debugging, use the device start debug coding block. Save the page and then head back to your phone and refresh the app. With the app refreshed, we can now head back to the App Studio and launch the remote debugging window by clicking on the remote debugging icon on top of the preview window. To the left of the window, I can see all clients connected to devices. I select the Android device, and now I get a direct communication channel to the app working almost as the Chrome debugging tools. For example, I can examine all objects that are stored in memory, explore the DOM, see network requests, and more. I also have an interactive JavaScript console that makes it possible to run JavaScript code on the device. For example, if I type in alert and run that command, I can see an alert box on the phone. So now back to our original issue, the script that uses a value from device platform to show a message to the user telling them which operating system the app's running on. So if I type console.logDevice.platform, I get the result from our phone. And here it says Android with a capital A, but in our script, I remember that we had Android with a lowercase a. This is probably the problem, so I'll head back to the Aquro App Studio and fix that in our script, then retest the page on the phone. Hooray, it works. When you're done using the remote debugging tools, don't forget to disable them. Having remote debugging activated might impact your app performance and stability, so never leave remote debugging on once you're done using it. Remote debugging is your third tool for debugging and troubleshooting apps developed in a Aquro platform. Remote debugging is available for all premium apps in the Aquro App Studio. And now, we've come to the end of this video showing you how to use the built-in debugging window, Chrome development tools, and finally, the Aquro remote debugging tools for troubleshooting and debugging your apps. Hopefully, you'll be able to squash out those pesky bugs a little bit easier now.